Hello, everyone. This is Viviana Jaramillo, PhD student in the Monogastric Nutrition Laboratory of Dr. Hans Stein at the University of Illinois. Today, I will discussing additive effects of 25-hydroxy vitamin D3 and microbial phytase on digestibility of calcium and phosphorus, bone biomarkers, and blood vitamin D3 metabolites in growing pigs. Vitamin D3 is a fat-soluble vitamin with several functions such calcium and phosphorus homeostasis and bone metabolism. Cholecalciferol is the main source of vitamin D in pig diets, but is inactive and must be hydroxylated to 25-hydroxycholecalciferol in the liver. And then a second hydroxylation occurs in the kidney to produce 1,25-dihydroxycholecalciferol, which is the active form of vitamin D3. Dietary 25-hydroxycholecalciferol 25D3 is available as a supplement for pigs, and because the 25 vitamin D3 is already hydroxylated, only the second hydroxylation in the kidney is needed. This thus increases the conversion efficiency to calcitriol compared with the conversion of cholecalciferol. On the other hand, in diets for pigs based on cereal grains, phosphorus is bound in phytic acid, which is the reason phosphorus digestibility in grain-based diet is low. However, use of exogenous microbial phytase in diets for pigs results in hydrolysis of the ester bonds between phosphorus and phytate and increased availability of free calcium, increases calcium and phosphorus digestibility. Vitamin D3 and phytase have different sites and modes of action. Therefore, using both simultaneously is likely to result in a synergetic effect. In fact, previous data from our laboratory have shown that the effect of using 25 vitamin D3 plus phytase in late gestation sows is additive. An additive effect means that the effect of each product does not depend on the positive effect of the other, but when used together, the response is even greater. However, there is a limited information about a possible additive effect of 25 vitamin D3 and supplemental microbial phytase in diet fed to growing pigs. Therefore, the hypothesis for this experiment is that effects of 25 vitamin D3 and microbial phytase on parental total tract digestibility and standardized total tract digestibility of calcium and phosphorus in diets fed to growing pigs are additive, and that both will result in increased serum biomarker for bone synthesis, FGF23 protein, and optimal vitamin D3 metabolites status in plasma. Moving to materials and methods, 5 corn soybean meal diets were formulated. The positive control diet containing total calcium and phosphorus at the recommended levels for 25 to 50 kilograms growing pigs, based on NRC 2012. 4 negative control diet were formulated with 20% less calcium and phosphorus than the positive control diet. A negative control diet without any additive. 3 additional diets were formulated by supplementing the low calcium and low phosphorus diet with either 15 micrograms per kilo of 25 vitamin D3 high D or 500 phytase unit of high phosphorus or both. 60 growing males pigs with a body weight of 25 kilos were allotted to one of the 5 diets in a randomized complete block design. 3 blocks with winning group at the blocking factor. Each block had 20 pigs, 4 pigs per diet, for a total of 12 replicates pigs per treatment. Pigs were housed in metabolic craters for 13 days. The initial 5 days were considered the adaptation period to the diets, and the adaptation period was followed by 5 days of fecal collection using the marker-to-marker procedure. 2 samples of blood were taken on day 1 and day 13. Contrast coefficients were used to test the effect of calcium and phosphorus level between the positive and negative control diets. Second, the effect of 25 vitamin D3, the microbial phytase, and the interaction of both. Let's move on the results. I will only present the measurements that showed a statistical significant difference. The apparent total tract digestibility of dry matter was higher in the negative control diet compared with positive control. This is likely due to the negative impact of high calcium levels on nutrients absorption and digestion efficiency. The standardized total tract digestibility of calcium was graded in pigs fed diets containing phytase because phytase increased the calcium availability. However, 25 vitamin D3 increases calcium digestibility just in absence of phytase, likely due an increased concentration of 125 vitamin D3, which increased from cellular calcium absorption. The standardized total tract digestibility of phosphorus was increased when pigs were fed positive control diets, mainly due to the inorganic phosphorus source. Phytase increases digestibility by releasing it from phytic acid. Similarly, 25 vitamin D3 improves phosphorus digestibility but without an additive effect. For bone biomarker response, we analyzed osteoblast markers such as bone-specific alkaline phosphatase and osteocalcin for bone formation and type 1 collagen for bone resorption. Additionally, we measure FGF23 protein due to its role in regulating 1-alpha hydroxylase in response to phosphorus level. We did not find significant difference between treatments for the majority of the bone biomarkers. However, the osteocalcin, which is a calcium binding protein related with anabolic bone formation, increases when vitamin D3 25 or phytase was added to the diet, indicates that osteoblast activity and therefore bone tissue synthesis was stimulated by the diets containing both. The osteocalcin, which is a calcium binding protein related with anabolic bone formation, increases when 25 vitamin D3 or phytase was added to the diet, indicates that osteoblast activity and therefore bone tissue synthesis was stimulated by the diets containing both. About plasma concentration of vitamin D3 metabolites on day 13, pigs fed diets with low calcium and phosphorus levels showed an increase in plasma 125 dihydroxy vitamin D3, likely due to increase of ETH activity, which stimulates its synthesis. In contrast, plasma levels of the active form of vitamin D3 were lower in pigs fed phytase containing diet compared to those fed 25 hydroxy vitamin D3, but remained higher than in the positive control group, likely due to sufficient available phosphorus level. Plasma 25 hydroxy vitamin D3 reflects if sufficient levels of vitamin D3 are available for synthesis of 125 vitamin D3. Plasma 25 concentration levels of vitamin D3 are available for synthesis of the active form 125 vitamin D3. Now, the 24-25 dihydroxyvitamin D3, which is a metabolite that has biological activity, is independent of the VDR or vitamin D receptor and stimulates growth plate development and regulates cartilage and bone healing. This metabolite was increased in plasma of pig fed positive control diet and phytase diet. However, the 24-25 was graded for pigs fed 25 vitamin D3 diet. This aligns with the increases in serum osteocalcin and supports the hypothesis that both metabolites may be needed for bone plate growth and mineralization of growing pigs' bones. Finally, conclusions. No additive effects between 25 vitamin D3 and phytase were found. Phytase and 25 vitamin D3 increases calcium and phosphorus digestibility in low calcium and phosphorus diets. Phytase and 25 vitamin D3 increased osteocalcin bone biomarker. 25 vitamin D3 increases the vitamin D3 metabolites status in plasma. 25 vitamin D3 increases the vitamin D3 metabolites in plasma. With this, thank you very much for your attention.